So who's excited to divide some monomials? Alright, so we have a property that we learned about in class about dividing monomials. When you divide the same base, so if you look at this first example, we have a base of x and we're dividing it by another x. So we have a property that tells us we can shortcut through this. If you're dividing the same base, you're going to keep same base of x. So the x stays the same. And then what you're going to do is you're going to take your two exponents, start with the one on the top, and you're going to subtract the one on the bottom. So 5 minus 2 is 3, so we get x to the third power. Done. Easy. Alright, here's another example. We are dividing the same base of m. We have an m divided by an m. So our property tells us to keep the same base of m. And then you take the 12 and you're going to subtract the 4. 12 minus 4 is 8. So we have m the 8th. See how fast these are? They're so great. Alright, here we are dividing our w's. A w divided by a w. So we keep our base of w. So that's the thing we want to remember. When you are dividing the same base, you keep the same base, and then you subtract your exponents. 25 minus 9 gives us 16. Over here we are dividing some bases of n. N divided by n, you keep your base of n, subtract 11 minus 9 is 2, so we get n squared. I don't have any examples up here with numbers, but same is true for numbers. You know, if you have 3 to the 5th power over 3 squared, a lot of times people want to take the 3 and divide it by the 3 and get 1. 3 divided by 3 is 1. However, we want to do a shortcut through the problem. We don't actually divide the bases. So if you notice that a problem is asking you to divide the same base, you keep the same base of 3, and then you take the exponents. 5 minus 2 is 3, so we get 3 to the third power. So when you are dividing monomials, if you're dividing the same base, keep your same base, subtract your exponents.